Okay, so you guys have sent in some really interesting stuff about AI,
Yeah.
um, and specifically about how to make AI something that, we can trust more.
Hmm.
We've got it all here, and we're going to try to get into it. But first, do you want to just quickly introduce yourself?
Yeah, sure. I'm a researcher in AI, and I've been really interested in how to make AI more trustworthy.
Awesome. Yeah, it's a hot topic these days.
Yeah.
And I think it's important, right? We're hearing a lot about AI, how it can do all this incredible stuff, but, is it always getting it right? I mean, that's kind of the big question here.
Yeah, I think there's a lot of hype about AI and how accurate it is, and the reality is more complex than that. I mean, AI can make mistakes like any other technology.
Right. And the thing is, it makes mistakes in ways that are sometimes hard to like spot.
Yeah,
It's
exactly.
not always obvious, like, oh, okay, this is
Yeah.
wrong.
Yeah.
So in this deep dive, what we want to do is kind of get under the hood and figure out like why AI isn't always spot on.
Yeah.
And the sources you guys sent in point to this really cool approach for like how to tackle that. So before we get into solutions, maybe let's just take a minute to talk about why AI gets things wrong sometimes. What are like the fundamental reasons why a single AI might not always give us the correct answer?
Yeah, I think one of the biggest reasons is that AI is only as good as the data it's trained on. So if you train an AI on a data set that's incomplete or biased, then the AI is going to reflect those limitations. Like, for example, if you train an AI only on pictures of cats, it's not going to be very good at recognizing dogs
Right.
because it's never seen one before.
Doesn't have that frame of reference. It's like trying to learn a language, but you've only ever been exposed to one dialect.
Exactly.
Right. You could have a hard time understanding people who speak a different dialect.
Mm.
And so with AI, it's the same kind of thing. It's like if the data is limited, the AI's understanding of the world is limited. And that's a
Yeah.
huge problem, right? Especially when we're talking about AI being used for, important decisions
Yeah, I think that's a great point.
like, medical diagnoses or, financial stuff. You really want to make sure that the AI has a broad, well-rounded data set to learn from.
Exactly. And I think that's one of the big challenges in AI research right now is how do we get these high quality data sets that are really representative of the real world?
Totally. And, you know, even if you do have a good data set,
Hmm.
it's not always enough because
Yeah.
sometimes the questions we're asking AI are ambiguous.
Right.
Like it's not always a clear cut, yes or no answer.
Exactly. Like if you ask an AI, is this picture art?
Yeah,
That's a really hard question for an AI to answer.
it's objective, right?
It's subjective. There's no right or wrong answer. And so in those situations, AI has to rely on probabilities, which means that it might give you a slightly different answer every time you ask it the same question.
Looks like flipping a coin almost, right?
It's like flipping a coin.
Or like, you ask five different people for their opinion on something and you might get five different answers. And
Exactly.
they might all be valid, right?
Yeah, right.
It's just a matter of perspective. And I think that's something that we have to keep in mind when we're interacting with AI is that it's not always going to give us a definitive answer, especially when we're dealing with these kinds of, ambiguous or subjective questions.
Yeah, exactly. And I think it's important for AI systems to be able to communicate their uncertainty.
Mhm.
So, instead of giving you a definitive answer that might be wrong, it should say, I'm not sure.
Yeah. That's a good point. Like it's okay to admit that you don't know.
Oh, right. Exact.
It's better than making something up.
It's better than making something up.
And then, of course, there's always the possibility of chance errors,
Mhm.
right? Like, even if an AI gets something right once, it doesn't necessarily mean that it's going to get it right every time.
Oh,
It could
right.
just be a fluke, right?
Exactly. Yeah, like it's kind of like if you flip a coin and you get heads 10 times in a row, you're not going to assume that the coin is biased, right? You're just
Yeah.
going to assume that you got really lucky.
Statistically unlikely, but possible.
Exactly. And it's the same thing with AI. Like if an AI gets something right once, it could just be a fluke. It doesn't necessarily mean that it understands the underlying concept or that it's going to be able to replicate that success in the future.
So, with all that in mind, we've got these kind of built in limitations to AI, and yet we're seeing AI being used in more and more areas of our lives. So, how do we address this? How do we make AI more trustworthy? And that brings us to this really cool solution that your sources talked about, which is this idea of using multiple AIs to check each other's work.
Yeah, I think that's a really promising approach.
It's called, I believe, the wisdom of the AI crowd.
Yeah, wisdom of the crowd.
Can you explain a little bit about how that works? Like, how does using a team of AIs actually improve the reliability of the results?
Yeah, so basically the idea is that instead of having one AI try to solve a problem, you have a whole bunch of AIs, like maybe 9 or 10, all work on the same problem independently, and then you compare their answers. And if most of them agree, then you're more likely to have the right answer. Like imagine you're trying to figure out if something is a cat.
Okay.
You could ask one person and they might say, yeah, I think it's a cat. But if you ask 10 people and 9 of them say it's a cat, then you're going to be a lot more confident that it's actually a cat.
Right. It's that collective knowledge.
Yeah.
Right? It's like, the old saying, two heads are better than one.
Exactly. And it's the same thing with AI. If you have multiple AIs all working on the same problem independently and they all come to the same conclusion, then you're more likely to have the right answer.
Makes sense. And in the sources that you sent, they actually laid out 3 key principles that underpin this whole approach:
Right.
diversity, reproducibility, and repeatability. So let's start with diversity. Like in the context of an AI team, what does that actually mean?
Yeah, so diversity in this context means that you want each AI on the team to have been trained on a different data set. So for example, one AI might be trained on images of cats from North America, while another AI might be trained on images of cats from Europe. And that way, they'll each have a slightly different perspective on what a cat looks like. And when they combine their knowledge, they're more likely to be able to identify a cat accurately, no matter what part of the world it comes from.
Interesting. So it's almost like having, experts from different fields all weigh in on a problem.
Right.
Like
Right.
you might have a biologist and a chemist and a physicist all looking at the same thing, and they're each going to bring their own unique perspective to the table.
Exactly.
And then by combining their knowledge, you're more likely to get a more complete understanding of the problem.
Yeah, absolutely.
So that's diversity. What about reproducibility? Like how does that contribute to the trustworthiness of the results?
Yeah, so reproducibility is all about making sure that an AI can consistently produce the same results, even when the input is slightly different. So, for example, if you have an AI that's trained to recognize cats, you want to make sure that it can still recognize the cat, even if the cat is in a different pose or if the lighting is different.
Okay, so it's not thrown off by like minor variations.
Exactly. You don't want it to be thrown off by minor variations because if it is, then that means that it's not really understanding the underlying concept of what a cat is. It's just memorizing a bunch of specific examples.
Got it. So it's about making sure the AI is actually learning the concept, not just memorizing specific instances.
Exactly.
Okay, that makes sense. And then the third principle is repeatability. What's that all about?
So repeatability is about making sure that the AI can consistently produce the same results over time. So, if you run the same query through the AI today and then you run it again tomorrow, you want to make sure that you get the same answer both times.
So it's about consistency over time.
Exactly. And this is important because it means that you can trust the AI to give you reliable results, even if the conditions change. Like, for example, if you're using an AI to control a self-driving car, you want to make sure that it's going to make the same decisions every time, even if the weather is different or if the traffic is heavier.
Right. So you're not going to have the AI, certainly slam on the brakes for no reason just because it's a little bit cloudy outside.
Exactly.
Okay, so we've got these 3 principles: diversity, reproducibility, repeatability. How do they all come together in this wisdom of the crowd approach? Like, can you walk us through an example of how the system would actually work in practice?
Hmm.
Let's say, for example, we're trying to figure out if a photo is of a cat.
Sure. So let's say you have a photo and you want to know if it's a cat. You would submit that photo to the system, and the system would send it to a team of 9 AIs, each of which has been trained on a different data set.
Okay.
So one AI might be trained on images of cats from North America, another one from Europe, another one from Asia, and so on.
So we've got our diverse team ready to go.
Exactly. And each of those AIs would independently analyze the photo and try to determine whether it's a cat.
Okay.
And let's say that 6 of the AI say it's a cat, and 3 of them say it's not a cat.
Okay, so we've got a majority saying cat, but not a unanimous decision.
Right. So at this point, the system wouldn't just say, okay, it's a cat, because we don't have a high enough level of confidence.
Right.
Remember, we want to make sure that we're getting the right answer. So what the system would do is it would send the photo back to the same 9 AIs again, but it would slightly change the photo each time. So for example, it might crop the photo a little bit, or it might adjust the brightness or the contrast.
So it's introducing those little variations to test the reproducibility.
Exactly. And it would do this 3 times in total. So the AIs would see the photo 3 times, each time with a slightly different variation. And each time, they would independently analyze the photo and try to determine if it's a cat.
Okay. And this is where the repeatability comes in.
Exactly. So let's say that the results from the 3 rounds are as follows. In the first round, 6 AI said cat. In the second round, 7 AI said cat. And in the third round, 5 AIs said cat.
Okay, so we're seeing some fluctuation there.
Right. So now the system has to decide whether to say cat or not cat or I don't know.
Right, because it's not a clear-cut case.
Right. And the way it makes that decision is it looks at 2 things. First, it looks at the number of AIs that agreed on the answer in each round.
Okay.
And second, it looks at the confidence level of each AI. So for example, if an AI is 99% sure that the photo is a cat, then that's going to carry more weight than an AI that's only 50% sure.
Right, it's factoring in how sure each AI is in its assessment.
Exactly. And so in this case, the system would see that in 2 out of the 3 rounds, at least 6 AIs agreed that the photo is a cat. And it would also see that the average confidence level of those AIs was pretty high. So it would probably conclude that the photo is a cat.
Right, so even though it wasn't unanimous and there was some variation, the overall trend and the confidence level suggest that cat is the most likely answer.
Exactly. And I think that's a really important point. Like, we're not looking for perfection here. We're just looking for a reasonable level of confidence.
Yeah, because in the real world, we rarely have perfect information to work with.
Right.
So it's about making the best decision possible
Yeah.
with the information that we have.
Exactly.
So this wisdom of the crowd approach, it sounds pretty promising.
Yeah.
What are like the main advantages of using this kind of system?
Well, I think the biggest advantage is that it's more likely to give you the right answer
Like, okay.
because you're not relying on a single AI, which might be biased or might make a mistake. You're relying on a whole team of AIs that have been trained on different data sets and they're all working independently. And so if they all come to the same conclusion, then you're much more likely to have the right answer.
So it's spreading the risk, so to speak.
Exactly. And another advantage is that it can help to identify cases where the AI is uncertain. So, for example, if you have a photo that's really ambiguous and the AIs are all over the place in their answers, then that's a sign that the AI might not be able to give you a reliable answer. And so, in those cases, it's better to just say, I don't know, than to give you an answer that might be wrong.
Right, because sometimes admitting that you don't know is the smartest thing you can do.
Exactly.
And the sources mentioned that this whole approach is actually more practical in the real world than trying to train a single AI to handle every possible situation perfectly.
Yeah, that's right. I mean, training a single AI to be perfect is incredibly difficult, if not impossible, because there are just so many different possible scenarios that the AI could encounter. And so it's much more practical to have a team of AIs, each of which is specialized in a particular area.
Right, it's like a division of labor.
Exactly. And then you can combine their knowledge to get a more complete understanding of the problem.
That makes a lot of sense. But of course, no system is perfect. So what are some of the limitations of this wisdom of the crowd approach?
Well, one limitation is that it can be computationally expensive to run a whole bunch of AIs at the same time, especially if you're doing it multiple times for each query, like we were talking about before.
Right, it's a lot of processing power.
Exactly. And another limitation is that it's still possible for the AIs to all make the same mistake, especially if they were all trained on similar data sets. So, for example, if all the AIs were trained on images of cats that were taken in well-lit studios, then they might not be very good at recognizing cats that are in the shadows or that are partially obscured.
So the diversity of the data is still really important.
Exactly.
You can't just assume that because you have a team of AIs that they're all going to have different perspectives.
Right?
We have to make sure that they're actually trained on different data.
Exactly.
And then, this approach seems like it would work really well for things like image recognition.
Right.
But what about more subjective questions?
Yeah, I think that's a good point. I mean, this approach is really good at answering questions that have a clear right or wrong answer, but it's not as good at answering questions that are more subjective or open-ended. Like, for example, if you ask the AI, what's the meaning of life?
Right.
You're not going to get a very satisfying answer.
It's going to be a lot of head scratching.
Yeah.
Okay, so this approach is really promising, but it's not a silver bullet.
Right.
There are still some limitations to be aware of. But, it's a step in the right direction. And I think it's really exciting to see how this kind of technology is being developed to make AI more trustworthy.
Yeah.
And I think it's important to remember that AI is still a relatively new technology. And so it's got to take time for us to figure out all the kinks and make it as reliable as we want it to be.
Yeah, definitely.
And, one of the things that I thought was really interesting in the sources that you sent is that they talked about how this whole approach of using multiple AIs
Hmm.
can actually help AI to learn and improve over time.
Yeah, that's right.
Like, if the AI is uncertain about something, that's actually a valuable piece of information
Mm-hmm.
because it tells the developers that they need to improve the training data or the algorithms. And so by using this approach, we can actually help AI to become more accurate and more reliable over time.
Yeah, I think that's a great point. I mean, it's kind of like how we learn as humans.
Uh-huh.
We make mistakes and we learn from those mistakes. And it's the same thing with AI. If we can create systems that can identify their own errors and learn from those errors, then they're going to become much more powerful and much more reliable.
Right. So it's almost like a self-correcting mechanism.
Exactly.
That's really cool. And, the sources also used a really great analogy to explain how this whole system works, which is the analogy of a team of chefs.
Right.
Can you explain that analogy for our listener?
Yeah, sure. So imagine you have a team of chefs and they're all given the same recipe and they all go into their kitchens and they all make the dish independently.
Okay.
And then they all bring their dishes out and they all taste each other's dishes. And if all the dishes taste good, then you know that the recipe is good.
Right.
But if some of the dishes taste bad, then you know that there's something wrong with the recipe. And so you need to go back and revise the recipe until all the chefs can consistently produce a good dish.
So it's like the recipe is the AI model.
Exactly. And the chefs are the individual AIs.
You got it.
And so by having multiple AIs all cook the same problem, you can get a much better sense of whether the AI model is actually working correctly.
That's a really great analogy. It really makes it clear how this whole system works. So to kind of wrap things up, what are the key takeaways that you would want our listeners to remember from this deep dive into the wisdom of the AI crowd?
Well, I think the biggest takeaway is that AI is not perfect, but there are ways to make it more reliable.
Okay.
And one of the most promising ways to do that is to use multiple AIs to check each other's work. And by doing that, we can create systems that are more accurate, more trustworthy, and more likely to give us the right answers.
Absolutely. And, I think the thing that I would add to that is that this whole approach of seeking multiple perspectives and verifying information, it's not just relevant to AI.
Yeah, that's right.
It's relevant to all areas of our lives, like whether we're making decisions about our health, our finances, our relationships, or anything else. It's always a good idea to get multiple opinions and to do our own research before we make a decision.
Yeah, definitely.
So, if there's one thing that you take away from this episode, it's that the wisdom of the crowd is a powerful tool.
Uh-huh.
And it's something that we can all use to make better decisions in all areas of our lives.
Yeah, I think that's a great point.
Awesome. Well, hey, this was a fantastic deep dive. Thanks so much for sharing your expertise with us.
Yeah, it was my pleasure.
And thanks to all of you for listening.
Yes, everyone. We'll catch you next time.
Bye.